Good morning, students. Today we are going to see periodicity of properties. So first we see the long form of periodic table, so which is proposed by Rank in the year of 1983, which is based on modern periodic law and states that the physical and chemical properties of elements are a periodic function of their atomic numbers. It is based on or it follows the Bohr scheme of classification, and the periodic table is classified into 4 blocks: S, P, D and F blocks, which is based on their electronic configuration. So this long form of periodic table is also called as Bohr's periodic table. So this is our periodic table of the elements. So the salient feature of periodic table is or structural features of the table is, so the long form of periodic table consists of 3 portions. So the left portion contains elements of group 1A and 2A. These are the electropositive metals, that is lithium, sodium, potassium and beryllium, magnesium, calcium. These are electropositive metals because lithium plus, sodium plus, magnesium 2 plus, calcium 2 plus. So அப்படிதான் எழுதுவோம். So these are most electropositive metals. It comes to right portion. So the right portion consists of 3A to 7A along with the 0 group elements. The elements of group 6A and 7A are highly electronegative non-metals. For example, carbon, nitrogen, oxygen, fluorine, phosphorus, chlorine, bromine, iodine. These are all the highly electronegative non-metals. What is the 0th group? It is a noble gas. So these are less reactive or least reactive chemically. So next it comes to middle portion. So the middle portion consists of transition elements, in which group 1B to 7B and 8. These elements have properties intermediate between those of non-metals and metals. And the inner transition elements comprising lanthanides and actinides are given in a separate place at the bottom of the table. These are the structural features of periodic table. So what are the groups present in the periodic table means 1A, 2A in the left portion, in the right portion 3A to 7A and 8. In the middle portion it contains 1B to 7B and 8. And the inner transition elements, that is lanthanide and actinides, are given in the bottom of the table. So these are the structural features of periodic table. So next we study period and groups. So what is period? The horizontal rows are called period, the vertical columns are called groups. So there are 7 periods are there, 16 groups are there. So in the first period it contains only 2 elements, that is hydrogen and helium. In the second and third period it contains 8 elements, which is short period, and also it is called as typical elements. In the in the fourth and fifth period it contains 18 elements, and while the sixth period contains 32 elements, seventh period is incomplete period. So what is the fourth period? That is potassium to krypton. So totally 18 elements present in fourth period. In the fifth period also rubidium to xenon. It also contains 18 elements. In the sixth period it contains cesium to radon. So totally 32 elements are there. In the 7th period it is an incomplete period. In the long period, the elements resembling the typical elements of 2nd and 3rd period are called normal elements. The rest of the elements are transition elements. So you note the period 3. In period 3, potassium and calcium, and this side in the right portion gallium to krypton. These are normal elements. So you see the 4th period. So in the 4th period, potassium and calcium are normal elements in the left side. In the right side, gallium and krypton. These are normal elements. In the center, scandium to zinc. These are first transition series. In the 5th period, rubidium, strontium and indium to xenon. These are normal elements. In the center portion, yttrium to cadmium. These are second transition series. In the 6th period, cesium, barium and thallium to radon. These are normal elements. And lanthanum, hafnium to mercury. These are third transition series. And also I said that the 7th period is an incomplete period. It contains some elements. So next we see the group. So the vertical columns are called groups. So the groups are numbered in Arabic numerals 1, 2, 3 like that. So the groups headed by hydrogen and helium are numbered as groups 1 and 2 respectively. And the groups headed by scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, copper and zinc. They are numbered as 3, 4, 5, 6 up to 12 respectively. The groups headed by boron, carbon, nitrogen, oxygen, fluorine and neon are numbered as 13, 14, 15, 16, 17 and 18 respectively. You take if the transition elements are taken out, the rest of the elements are called as normal elements except hydrogen and helium. So here I show some groups 1, 2, 13, 14, 15, 16, 17 and 18. In the first group, the elements are lithium to francium. In the second group, beryllium to radon. So like that I show 18 groups. The elements of each group analogs to one another. For example, the elements of group 1, namely lithium to francium, they are all have identical properties. Like that, the elements of group 18, that is noble gas, also have the similar properties. So next classification. So according to Bohr's, the elements are classified into 4 blocks. It is based on their electronic configuration, namely S, P, D and F block. What is S block elements? The general electronic configuration of S block elements is 1 NS 1 or 2. So the elements of groups 1A and 2A groups are called as S block elements. The 1A elements having electronic configuration is NS1 and the second A group have the electronic configuration is NS2. Okay. So next P block elements. The electronic configuration of P block elements is NS2 NP1 to 6 because P orbital contains maximum 6 electrons. So the elements of groups 3rd A to 7A and 0 group elements. So 3rd A group contain the electronic configuration NS2 NP1 and 4th A having electronic configuration NS2 NP2 and 5A means NS2 NP3, 6A NS2 NP4, 7A NS2 NP5 and 0 group elements having electronic configuration NS2 NP6. So next D block elements. These elements lying between S and P blocks have completely filled S and P orbitals, but the D orbitals are partly filled. The electronic configuration of D block elements is N-1 D 1 to 10 NS2. There are 3 series of D blocks. So first one is 3D series, that is scandium to zinc, which has electronic configuration 3D, (1 to 10) NS2, and 4D series yttrium to gadmium, that electronic configuration is 4D 1 to 10 NS2, and 5D series, that is hafnium to mercury, it has electronic configuration 5D 1 to 10 NS2. Then fourth one is F block elements. These elements have partly filled D and F orbitals. The electronic configuration is N-2 F 1 to 14, N-1 D 0 and 1 NS2. So lanthanides, that is cerium to lutetium 4F series, and actinides thorium to lawrencium, that is 5F series. These are called as F block elements. So what are the merits of the periodic table? In this periodic table, the elements are arranged on a more fundamental property, that is, it is based on atomic number. So based on the atomic number, all the elements are arranged. So the next point is the transition elements, which have the properties intermediate between S and P block elements, and inner transition element, that is lanthanide and actinides, have been given in a separate place at the bottom of the table, and due to separation of each group into A and B subgroups, and in this table complete separation between metals and non-metals has been made, and this table is very easy to remember and reproduce. And the greatest advantage of this periodic table is it is classified into, or it is divided into 4 blocks, that is S, P and D block elements. So what are the demerits? The position of hydrogen in the periodic table has not been solved, and helium with 1s2 configuration, but it is placed in the or along with the 0 group elements with the NS2 NP6 configuration, and it is unable to include the inner transition elements in its main body, and the periodic table doesn't reflect the exact distribution of electrons among all the elements. Thank you.